Hey guys, in this video we'll be going over the stack and then stack instructions, so stick around for that one. So what is a stack? A stack, let me type this out, is a type of data structure that is going to contain a array of data, and it is in the format of first in and last out. So a real life example that people normally associate with a stack. Some people say like a stack of plate, a stack of books. So let me draw here a stack of books. So with the square. So we're gonna assume this over here is a book. This square over here is a book. And if I want to add another book to it, that's called a push. I'm pushing one more book on top of the stack. So that's a term we refer to adding. So let me add a few more books over here. So one, 2, 3. Actually, let me put different colors because each one of this is a different type of data. So all of them has some type of different data. Let's say have different numbers and so forth, different values in it. So this is our book. It's our book stack. And if you want to add something, we refer that as a push. Let me put it here, push. So we're pushing something into the stack. We're adding data into it. Well, let's say if I want to access this book over here. Oh, let me change the colors that represent that. It's orange. Okay. Let's say I want to get the orange book. Well, to do that, I can't just... Well, I can, but normally to access this book, we are going to have to remove those books on top to access the book. So what we did, this delete, we refer to that as a pop or push. So let me change colors. So those two books that were removed, not pop or pull, my bad. A pull, that's what the 6502 actually refers to, or sometimes refer to a pop. So we deleted those, we removed those two books in order to get this orange book over here. So to do that, we access this data. So let's say now you can, now that we can access this data, we can always pull or push as many books as we need. So we can add one here, can pop, add it back, and so forth. That's what a stack is. As you've noticed, the red one was the first in. So when the first one in is the last one out. So we're gonna keep stacking. So let's say that's done, and then when you're done with that data, that goes out. So the first one, the red book, was the last one. So that's why the first in, last out. And a quick example. Sometimes when I'm making a game, so let's say this is a game over here, and this is our guy over here. Let's say for what I like to do normally is let's have this another box over here, and that's our memory. So memory location right here. Well, what I like to do is, for example, if I wanted to add a, so now let me add a menu over here. So this is our stack of data. It's the first one in, and then I will push this block of data for the menu. So then you see all the menu and so forth. The game is paused or not, whatever. It's pushed over here. Now that I'm done with the menu, I don't need it anymore. I can pull it off. So I pull it off of the stack, and now I can resume with my game. So that's an example, at least a big example. The 6502, we are looking at bytes of memory, not a whole menu. So now let me jump over the 6502 and show you guys the instructions and the stack pointer. Well, okay, so as you see over here in our 6502 emulator, we have the stack pointer SP, and it starts FF. Well, if you remember, the 0 page go to 0000, that's the absolute value, to 00 FF. So this is our 0 page. 0 page. But right after that, from 0100 to 01 FF, that's where our stack data is gonna be stored. So, and we're gonna start F01 FF and go all the way down to 00. So we have a lot of values to work with, but be careful, we can't overflow. And hence the name of the famous programming website, Stack Overflow, so we can go over and under. So as you see, FF actually represents these addresses. Okay, so let's go over the instructions in the mnemonics. So like I said, first you can push. Let's say I'm gonna push the accumulator, push A. So that's push accumulator, and we can also, while we're here, we can push. The only two things we can push: this accumulator or the stack. Not the stack, the processor status. So our flags. So we can push the processor status. Oh, misspell status. So that's the only two. Let me actually comment those two out as well. And all of those stack registers, all of them are implied. So we're really implying we're going to push the accumulator and pull the accumulator. And like I said in the other video of representation, we can also pull. So we can pull, just pick allow, I guess. Pull the accumulator. Let me copy and paste. Let me copy and paste this. Or you can pull the processor status. Pull the processor status. So that's how you can pull and push. So let's go over just to show you guys an example. So let's load A. Let's create a let's create a loop. Oops. Loop. You're gonna branch while not equals 0. I'm gonna go to loop. As you see, it always starts at 0. So let's increment y and transfer y to A. And we're gonna push the value in A. So then let's compare. Let's compare to how many times you're gonna do this. Let's say 5 times. So let's assemble and run, see if there's nothing wrong, and let's go to our location of our our stack is stored. Let me put over here 0 100 to 0 FF. So stack, and like I said, it's gonna begin from the top and go to the bottom. So let's say over here, where is it? Oh, right here, 01 FF. So let's reset. let's see if it works. So pushing A, gonna increment Y, transfer Y to A, and then we're gonna compare for value 5, the accumulator. It's not 0, so it's gonna keep branching. So let's go. Oh, I miss. As you see, one got stored at F. This is FF, FE. So 2. This is like compare. You're gonna branch. We set the program counter over here, and then we're gonna push A. So we're gonna. This is the stack pointer is gonna decremented. So it's got pushed. Here's the value 2. Now we're gonna increment Y, transfer Y to A, and so forth. As you see, all the values they start over here. So that works. So now, what we can do, we can pull the value. So let's pull the accumulator. Let's do that a few times, 5 times. Assemble. Let's go over here. B4. Even though it's going to increment to 5, it's not going to go to 5. 5 compared to 5. It is. So now let's go over here. Now it's done looping. As you see, I'm gonna push it. Now it's decrementing and it's changing the value. So 4 is gonna be FC. It's gonna be 3. So then FD, FE, and FF. As you see, we transfer to the accumulator. Well, you can as well, as you see, push the processor status, our friend over here. So let's just be careful, because if I let's say push the processor status, instead of PLA, it's gonna be a different. It's gonna push what's on top. So if you pull the accumulator, it's gonna go to the accumulator. If you push the processor status, the value is gonna go to the processor status, since both of them are only 1 byte. So let me run over here. Let's see, 1FF. See, all of them is all of this represents a byte, and all of this represents a byte, as you see over here. So if you're on top of the stack and you have a processor status and you pull the accumulator, it's not going to be the actual value. And something I just noticed, I could have used this to show you guys what's the value of the byte. Now that I think about it, for example, now that we know, a little bit too late, but let me load A with FF. So it's 1 1 1 was entirely 1. Let me push the accumulator and let me pull the processor status. Assemble and run in C over here. Could have used this to show you guys what's the actual value of the hex. Well, now if you need it, you can do this yourself as well. I just noticed that. Now this is all the major ones, and of course there's 2 more instructions for the stack, and those 2 more instructions are the TXS, so transfer the X register, or register X, the register X into the stack, so a giant number over here, and transfer the stack into X. Stack into register X. So let me show you as an example. Let me load. Let's. I shouldn't delete the loop. Let me do this again. Do this loop again. Increment Y. Transfer Y to A. Let's compare the accumulator. Let's say just 3 this time, and let's push A. So let me assemble and run over here. Just see if it works. 1, 2, 3, perfect. Now let me show you guys the transfer the stack to X. Let's look at the X. Let's look at this X tracer right here and run. As you see over here, it's pointing to the location. Let's see, FF, FE, FD, FC. So it's pointing to this location over here. So next time that we start a data, this is gonna start right over here. So if we were to let's pull A and do transfer X again. So let's assemble and run. As you see, now it's pointing an FD. So right over here. Where is it pointing at? So that's the transfer. Oh, can you spell wrong over here? It's transfer. Transfer the stack to X. So now we know where the, well, we already know over here, but let's transfer this value over here to X. And the other instruction, or mnemonic, is gonna transfer, transfer the register X into the stack. So now we're gonna change this value over here. We're gonna swap it out. So all we're doing is swapping it out. So we're gonna swap X with this. So if FD is 2, so FE should be 1. Actually, FE will be 0. Let me see. Let's load X with FE. Let's now transfer X into the stack. And let me assemble. Where is it? Let me see. FE, oh, of course. Forgot to say it's a hex value. So assemble, and then we're gonna pull the accumulator. Assemble and run. Oh, and to fix this, let's say let's load A for big value, like, I don't know, 50. So for assemble, I go step by step. 1, 2, 3. Oh, pass. Let's go to 50. Here it is. Let's load register the X with FE. Now let's transfer X to FE over here. It's perfect. And now we're gonna pull A, so it's gonna decrement, or actually increment since you're pulling, and then look at the value. So FE would be FF, and then you're gonna look at the value, which is 0. So just remember that you're actually incrementing, then looking at the value. As for the push A, you're decrementing and then storing to the value. So it's going to store, then decrement, and when you push, and this one's going to decrement and then retrieve. So that is the stack. In the next video, I'm gonna be over the subroutines. So that's it for this video, and see you guys in the next one. Thank you.